All right, we are factorising these now. We've just done it on the whiteboard, so these shouldn't be too hard. First thing you do is look at the numbers. Is there a common factor to the two numbers? 3 is common to both. So you pull out the 3. Is there anything else common? The x appears on the left-hand term. Does it appear on the right? Therefore not common. So what are we left with? It is as simple as that. Next one. We once again look at the coefficients, look at the numerals. Is there any numerals on the first one? So they're not common. I mean, you could say, oh, but 1 is common to both of them. But that's not going to help you. Pull a 1 out the front, you're still going to not have any help. So what's common? How many? Only one of them. So we pull out 1y and Dunskies. It's got in red there on the right-hand side. It says check your answers by expanding brackets. Okay. It also says there on the first question, it actually says divide each term by 3 to find the terms inside the bracket. That's basically what we've done by saying, okay, I pull a 3 out, what have I got left? And you guys will, you're dividing x by 3 and you get just x. You divide 12 by 3 and you get 4. Cool? So they're not too bad. All right, this next one we're starting to deal with slightly higher indices. So, okay, so common to it is x squared. What's left? Is everyone happy with that? Now, I just want you to be aware, I don't want you to think that we are subtracting them from it, not taking the x squared away. We've divided 2x squared by x squared, Cool? It is a division, because that is 2 times x squared, and we have divided it by x squared to bring it out the front. Cool? Okay. Because some people will say, oh, we've taken the x squared away. Well, no, because 2x squared minus x squared is 1x squared. Yeah? X squared. Because it still is an x squared. You've got like, yeah, 2 bus squared minus bus squared gives you just bus squared. Cool. All right, next one. We have some brackets. This is an interesting one. Some of you may recognize it from when we were doing the expansions. Well, that's a very good question. She's actually got it right, which is, well, scary. Get back. Don't. Jeez.
Wait. 5 plus 2y, then you square the bracket whatever.
You don't actually have to square it. I've got 5 times whatever's in the bracket, and I've got 2y times whatever's in the bracket, correct? Yeah. Okay. Why am I doing that? This works because those two brackets are the same. X plus 3, x plus 3. If those weren't the same, this method wouldn't work. But that's, remember, this is the split method. If you were given this to expand, this binomial product, you could use a split method rather than the FOIL method. We've accepted the fact that we like the FOIL method. You guys are happy with doing that. I'm happy with doing that. But the way they explained in the textbook the first time, and I explained, there is this split method that they do, where they split up that first bracket. Because what we're doing when we do the FOIL method is we're doing 5 times x plus 3. Then we're doing plus 2y times x plus 3. Cool? That's actually what they've got written here. 5 times x plus 3 plus 2y times x plus 3. So that's where it comes from. Is that all right? Yeah. Right.
Yeah, why isn't it x squared?
Why didn't what make what squared?
Why isn't it x squared?
Because we're not multiplying, remember?
Oh, yeah.
We are dividing. We are splitting it up. So what we've done is we've factorised it. If we expanded it, because we're not, well, we wouldn't, because at no stage is x multiplying by x. There is no x times x in that question at all. Okay, you've got 5 times x, and you've got plus 2y times x, but there is no x times x.
What if that plus 2y wasn't there?
Oh, that'd be a totally different question. And we'd have 5 times x plus 3 all squared. Okay, if that bit wasn't there. Okay, then you'd basically have your perfect square and a 5 outside it. Cool? But yeah, very different question. All right, next one, number 5. Looks hard. Well, it doesn't actually look hard at all. It looks more complicated. It's not. Numbers change. Process is the same. What number is common to both of those? Okay, so we pull a 2 out the front. A and
B squared.
yeah, highest power or the lowest power of B. You can take out the lowest power of each one. Okay, because when you divide numbers that have the same base, you subtract the indices. So when you take that out, you're going to end up with no B squareds left. Okay, so we've taken a 2 out the front. So what are we left with? 2 times what gives you 8, basically. 4A squared, and the B squareds cancel each other out. Minus, we've taken out a 2A, so they're gone, and that leaves us with B because we've taken out 2 of them. We're done. That all right? Double check yourself. 2AB squared times 4A. 2 times 4 is 8. A times A squared gives me A cubed. B squared times, there's nothing there, so it becomes B squared. 2 times, well, there's nothing there. A, there's nothing there. B squared times B gives you B cubed. I shouldn't say nothing there. It's basically timesing it by 1. You guys all right with that?